It's a cardioid. That's, that butt-looking shape, heart-looking shape. I mean, not because kids always say butt-looking shape, right? Okay, I made that thingy, right? Okay, ignore the circle. I'm just using the same picture, but that is a cardioid. Does it look like a butt? Whenever somebody says, it does not look like a heart now, does it? Whenever somebody says that, I say, wow, your butt looks like that. Okay, now we have to find the slope of this thing when theta is equal to pi over 3. Pi over 3 line is here, so about that slope. You know what I'm saying? So far so good? Okay, Matthew, do you have a question?
Oh no, I just want to say that cardioids always look like leaves to me.
Okay, leaf. Okay, better than butt. Okay. Okay, whatever. Okay. Now, then, of course, we have this equation, right? R is equal to 1 plus sine theta. So why don't we take the R over the theta? And that derivative is a slope, is it? Is it or isn't it? So derivative is slope. Okay, so we'll just take a derivative, and of course that gives us cosine theta, right? Okay, we'll evaluate that at pi over 3. And then cosine of pi over 3 is 1/2, right? Right. Does that slope look like 1/2 to you? Not even close, it's negative, right? Maybe negative 4/5-ish or something. It's definitely not positive 1/2 now, is it? So what the hell just happened? How come derivative is not the slope? Somebody, while you come up with a brilliant answer to that, I'm gonna throw something. So give me a brilliant answer. What's going on? Oh, come on, children.
Is it because dr over d theta is not dx over dy? So if we're just taking derivative of respect to theta, we're technically just doing 1 plus sine y equals to 1 plus sine x on the Cartesian coordinate and then find the derivative of it.
Yeah, it's a coordinate problem. See, this is what 1 plus sine theta looks like, right? Ah, that's ugly. Why am I lost this ability. Slightly better, right? On r versus theta coordinate, this is what it looks like. You know what I'm saying? 1 plus sine theta, oh my god. You should know what 1 plus sine theta looks like. And then at pi over 3, let's say it's about here, right? Pi over 3. Yeah, that does look like 1/2 now, doesn't it? You know what I'm saying? That's what we found. So it is a slope. The derivative is a slope in wrong coordinate, right? If you plot this as r theta in Cartesian coordinate, yeah, that is 1/2. But that doesn't mean it's 1/2 here, right? Because you're having that thing wrapped around in this circle, if you will. You know what I'm saying? That's what polar coordinate is. Think like this. See, this is a circle with radius 1, and you're wrapping the sine theta around here. You get it? This thingy around the circle. That's what polar coordinate is. So of course it's not gonna give you that. Well, then any other idea? Do you have any brilliant idea? And the other idea is, why don't we convert this into Cartesian coordinate then, eh? You've done that before. Do you remember, have you ever, because you learned this during pandemic now, right? So you're missing quite a bit, but Matthew.
I was just going to say, figure out how to make it into a vector would probably help.
Well, maybe. But I just want to show you this. Don't write this down because it ain't gonna work. But Every year, somebody on the test always tries this and see how ugly it's gonna get, okay? Watch this. So this is x plus y squared, right? X squared plus y squared, r squared. And this is, of course, square root of x squared plus y squared. And this is equal to y. Then you're gonna bring it over and square goes to, oh my God. You see how horrible that is? So we can scrap that idea. Right, so now, so this way failed. Well, and then this failed. We are running out of options, right? And then Matthew says vectors. Oh, explain how you mean by vectors.
Sorry, were you asking me something?
Yeah,
It's kind of
you mentioned converted into vectors. So yeah, that sounds interesting. So what do you mean by, oops, sorry. What do you mean by vectors?
I mean that you could get like a line, because the radius is basically a vector. It's just like a vector that sticks out of the origin. It's got a length and it's got an angle.
Mm-hmm.
So maybe if we could use the vector to figure out how to plot like a point at the tip of a vector, and then you could draw a line based on that.
You mean vector function? Oh. You mean something that looks like this now, right? Whoops, that didn't work. Hold on. Why is it my keyboard? Oh yeah, now it's working. So I think you're onto something. So you create this vector function that does this, right? Oh yeah, huh? So let's just think about that idea for a sec, because that's an interesting idea to entertain, isn't it? So this vector function, R of theta is our parameter now. Well, it has to have x of t and y of t in it. So what's our x and y then? That's a natural question to ask. This is going somewhere now, so what's our x and y now?
I guess there's we have the angle and we have the length of r, and we could make use of those to get the x and y coordinates.
Oh, okay. So I think we are almost there, right? If we can find x and y, then of course dy dx comes out naturally. We have done that before. So what is x and y? Because we only have one thing, r is equal to 1 plus sine theta, hey? We got that to work with. I'm gonna write it here, r of theta is equal to 1 plus sine theta. And then how do we, here's an idea. This x is equal to r space cosine theta, and y is equal to r sine theta, isn't it? Do you remember this relationship? The polar coordinate, Cartesian coordinate conversion thing, r cosine, r sine. You want me to show you where that came from, or can we just move on? I mean, I can show it to you. Who wants to see it? Okay, let's show it to you. Okay, this is what's going on. This is r, right? That's r, literally, that distance is r. And then this is theta. So how much is this adjacent side? Is that r cosine theta? And is this side r sine theta? Yeah! How that works out, huh? Wow, geometry. Everything is all related, huh? And we're still tying all of this all together now, so hang on. But only problem is r back then was constant. It was just a coordinate point. It's no longer constant, as you can see here, right? So what do? Does it have to be constant? Could we just put that function here? What do you say? Will this work? What I mean by that is 1 plus sine theta, you substitute it. 1 plus sine theta times cosine theta here. And then I'm gonna move this thing out a little bit. This is the beauty of live lesson, lively discussion. Like that, right? Will that work? Let's find out. Take out your TI-84s. Oh, for the people who's watching this video, this is not sponsored video. I didn't get a dime from Texas Instruments. Okay, so mode. Of course, we know how to graph this in polar, right? Oh, by the way, we've been working with degrees for a while, so change that back to radian. See, we could graph it like that, but that's not the point, right? The point is this way. We go to parametric mode, but lo and behold, this is parametric function, isn't it? X and Y. But will that work if I just substitute this for R, 1 plus sine theta, this is our R. Will that work? We shall see. I mean, if this works, I'm adding sorcery to my resume. I have this thing typed in, so I'll give you a few seconds to type it in, right? This thing E for X, and this thing E for Y. Ready? Are you ready? Let's see, fingers crossed. Oh my God. It works. It's alive. This is madness. Isn't it? I mean, you had your doubts, didn't you? So apparently this works. Of course, if you're going to graph it on the machine, you're not going to do it that way. You'll go to polar mode and do it that way. But just to prove a point, this scheme itself works. We can parameterize X and Y as a parameter theta, function of theta. Okay, once we have that, then we can take a derivative with respect to theta. You know what I'm saying? Okay, before I do that, I load product rule, so I'm not going to do it like that. So this is, I'm going to distribute cosine theta plus sine theta cosine theta, and then, ooh, that's still product rule. So remember identity? 2 sine theta cosine theta is equal to sine 2 theta. So then we'll take half and then sine 2 theta. You get it? Oh, that's ugly theta. You get it? The other one I'm going to distribute as well. So this is sine theta plus sine squared theta. And we could convert that into cosine 2 theta, but we don't load the chain rule as much. So we'll just work with this. Good. So the next natural thing to do is, of course, dx over d theta A. So this becomes negative sine theta plus, and that half is going to be cancelled by the chain rule, so it just becomes cosine 2 theta A. And then dy over d theta. We are using theta as parameter t kind of thing. And then this becomes cosine of theta, and this becomes 2, right, power rule. Why is my handwriting so ugly today? I think it's slippery glove. 2. Still ugly, huh? Hold on. I think I'm gonna get this sine theta, and then chain rule, cosine theta. You get it? But then this one, oh, 2 sine theta, cosine theta. I have a cosine 2 theta. So yeah, symmetry is such a beauty, right? Do you naturally crave symmetry? Or do you personally prefer asymmetry? I mean, I always like things symmetrical. Symmetry is beautiful. And there is a study of mathematics that starts with a study of symmetry. It's called abstract algebra, group theory. That's a beautiful theory, by the way. Actually, I hate it, but people say it's a beautiful theory. Okay, so far with me? Then dy over dx, I'm going to change the color. So dy over dx, of course, is dy over the theta. Remember this? Over dx over the theta, isn't it? You know what I'm saying? So we take this thingy over that thingy. So we have cosine theta plus sine 2 theta over negative sine theta plus cosine 2 theta. How about that, huh? That's great. Well, then, could we evaluate it and see if we get our answer that we want? Dy over dx at theta is equal to pi over 3 was what we started this thing with, right? So let's substitute pi over 3. So cosine pi over 3 is 3 over 2. And this here, sine 2 pi over 3, that's 1. I mean 1/2. And then sine pi over 3 with a negative sign, so negative root 3 over 2. And then cosine of 2 pi over 3 is negative 1/2. Oh, lo and behold, this thing gives you negative 1. Let's go back here. I'm going to throw that little tangent to show you. Does it look about negative 1 to you? Yeah, it does, doesn't it? You know what I'm saying? This is amazing, huh? Dang. Okay, that was great. So let's summarize. What do? We parameterize this polar coordinate with this simple formula, the convergent formula, r cosine theta, r sine theta, which is just geometry, right triangle trig. Okay? Now, having said that, then we can just do our usual dy over dx in parametric function. With me? Okay, let's go to prompt B. Our prompt B says, find the point of this where the tangent is horizontal or vertical. What? Okay, I'm gonna copy this and paste it here. Okay, this is part B now. Let's see, where is it horizontal? Here, 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 right? If we have to guesstimate, oh, pi over 2, that sure looks like 7 pi over 2. This sure looks like 11 pi over 2, right? Where is it vertical? Well, here, here, there. Okay, so pi over 6, 5 pi over 6, and 3 pi over 2. You know what I'm saying? Okay, so let's do this. This is B. Okay, we'll do vertical first. Okay, here's our slope. How do you achieve vertical tangent, vertical slope? It's not a trick question.
Oh, having a 0 on the denominator.
Yeah, this denominator needs to be 0. That's undefined slope, isn't it? In other words, you set dx over the theta, this thing to 0. That's what the denominator is. You get it? So vertical means dx over the theta is equal to 0. That's what we want to do. Okay, so what we have is negative sine theta plus cosine 2 theta is equal to 0. Oh, you remember this trig equations last year? Oh yeah, everything is all tying in together, all the way starting from geometry, way up to pre-calculus last year. And of course, this is algebra now. Oh, so we want to convert this into sine now, don't we? So negative sine theta, and this is 1 minus 2 sine squared theta, eh? Rearrange, multiply negative 1 on both sides, so we have 2 sine squared theta plus sine theta minus 1 is equal to 0, eh? Factor 2 sine theta minus 1, and Oh, that's ugly. Sine theta plus 1a. That tells you sine theta is equal to 1/2, or sine theta is equal to -1, lo and behold. So we have theta, solution set, pi over 6, that one, 5 pi over 6, that one, and this, of course, 3 pi over 2. Wow, that's amazing, huh? Yeah. Okay, then we should do horizontal, right? Okay, let's do that. I'm gonna change the color. I'm gonna do it here. Okay, we set this slope to 0, right? This whole thing becomes 0. Zero slope is horizontal, meaning your numerator is equal to 0. Good. So another way of saying that is that thing is equal to 0, dy over d theta. If you think of it as a particle motion, and when it's vertical, there's no x movement, just a y movement. So x movement, the x velocity, x component is 0. When you're moving that way, sideways, that means velocity y component is 0. There's only x movement. You know what I'm saying? So we can tie this into physics even, because that's after all what we're doing here, right? So you want to say dy over d theta is equal to 0 here. You get it? Oh, I wish I can remember the cosine theta plus sine 2 theta. So this one is cosine theta plus sine 2 theta is equal to 0. Good. Okay, we know how to do that. Cosine theta plus, we have to convert this back to 2 sine theta. Cosine theta is equal to 0, eh? Then factor, so we have cosine theta here. And then we have 1 minus 2, 1 plus 2, sine theta is equal to 0, eh? Good. Okay, that means cosine theta is equal to 0, or sine theta is equal to -1/2, eh? Okay, so now solution set. This one is, of course, pi over 2. Good. That one right here. And this one, oh, 7 pi over 2. Good. Okay, and wait a minute, pi over 2 as well as 3 pi over 2. Uh-oh, do you see trouble bubbling? And this one, finally, 11 pi over 2.
Isn't it over 6?
11 pi over 6. Oh my God. Nice catch. Over 6. Right? Why is that troubling? Because we have 3 pi over 2 there and 3 pi over 2 here. We have a conflict. Which way is it? The picture suggests it's vertical right here. But how do we justify this? Is it vertical or is it horizontal? Josh.
Mr. K, can I think, wait, wouldn't, if something's both vertical and horizontal, wouldn't it always be vertical since it's 0 over 0 for the derivative, so it's undefined?
Hold on to
That's-
that thought. I'll be right back. I'm gonna turn the video off for a sec because I have to go close my window. Okay?
Yeah, okay.
I'll be right back. I'm back. Sorry about that in the middle of recording, but I hear that leaf blower going outside and my bedroom window was open. And this gardener will just spit all kinds of fume and dust into my bed. Oh, I cannot have that. So I have allergy problems. Okay, Josh, continue your thought.
Yeah, so what I was saying was since 3 pi over 2 is both quote unquote vertical horizontal, but if we do dy over dx, we're gonna get 0 over 0, right?
Oh, yes, 0 over 0. Why does that sound so familiar? So keep on suggesting. We're on to something. You are on to something. If we have 0 over 0, then what?
It's undefined or indeterminate form.
And yeah, so what do? I think that's part of this chapter, right? So our problem is that theta is equal to 3 pi over 2, right? So this dy over dx looks like this. Which one is, this is the numerator. We have cosine theta plus
Do you use L'Hopital's rule?
yeah, of course, we L'Hopitalise it, right? And then denominator is negative sine plus cosine 2 theta. I mean, this would have been such a perfect video other than the leaf blower gardener guy, cleaner. I hate him. I don't know why we keep hiring, that this building hires that guy. We should fire him. Right? This numerator will approach 0 as we are going towards up here in the curve, 3 pi over 2, right? This entire slope, this is dy over dx, the numerator approaches 0, denominator approaches 0. So why don't we take a limit and theta approaching 3 pi over 2 and L'Hopitalise this whole thing, huh? That sounds like a brilliant idea now, doesn't it? Yeah. So this is limit theta approaching 3 pi over 2, and then take a derivative, eh? So this becomes negative sine theta plus 2 cosine 2 theta over, this becomes negative cosine theta minus 2 sine 2 theta, eh? Let's check. If we substitute 3 pi over 2, this becomes 3 pi over negative 1, so it becomes positive 1. Good. And this becomes cosine 2 pi, 3 pi, cosine 3 pi. So this becomes, what does it become? Negative 1. So you have a numerator is 0. Right? Wait. Let's do that again. This thing becomes 3 pi over 2. So cosine 3 pi. Cosine 3 pi is negative 1. Good. And then this thingy becomes negative and positive 1. So numerator is 0. 8.
Wait, what happened to the 2 cosine 2 theta?
Huh?
What happened to the, wait, wouldn't 2 cosine 2
oh my God.
Theta be negative 2?
This is negative 2. This is negative 2. This becomes positive 1. So your numerator is negative 1 at the moment, right? Okay, let's check the denominator. So we start with the L'Hopital right here. Let's see what the denominator becomes. This becomes 0, correct? This also becomes 0, eh? Sine 3 pi. So this is 0. Negative 1 over 0. Well, this does not exist, right? Undefined. The limit does not exist. Which means this is vertical. Get it? Undefined slope. Whoa! So we have to go back and take this guy out. Wow, 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 right? Okay, now one last thing left. We have to find the second derivative, and this is ugly. Second derivative meaning this thing. And we already forgot how to do that, right? Okay, the trick is this. We have to find, here's a little bit of theory back. This is just, right? So if we let this thingy be z, you know what I'm saying? That's just dz over dx. And we can play this game, this z. What we mean by z is this thingy. You know what I'm saying? dy over dx. Then this thing is back to dz over d theta over dx over d theta. Is the theory here. You get it? So all we have to do is we let z become our thingy. What is it? Cosine theta plus sine 2 theta over negative sine theta, right? Plus cosine 2 theta. Then we can find dz over d theta. Oh no, quotient rule. It's awful, right? Let's suck it up and do it. dz over d theta, I'm going to zoom in a little bit, will be derivative u prime v, so u prime negative sine theta plus 2 cosine 2 theta times v, the denominator, negative sine theta plus cosine 2 theta. Good. Okay, and then plus and minus u. So we have cosine theta plus sine 2 theta times v prime. So we'll have negative sine v prime, so cosine now. My tablet is frozen. Okay, now it's cosine theta minus 2 sine 2 theta. Good. All over the amazingly straight line. That messed up. Whenever I try to do too much, this always happens. Okay. All over amazingly straight line. And this denominator, negative sine theta plus cosine 2 theta squared. This is a gigantic mess now, isn't it? Then on top of that, we are going to have to, well, therefore, this thingy. Remember that thingy is just here, this thingy over this thingy. So we have to find dx over d theta. Well, we'll recycle our work. Dx over d theta is here, right? Negative sine plus cosine 2 theta. That looks exactly the same as this. So, I'm going to recycle this writing. So all I have to do is copy this, paste it, bring it over here, put equal sign, and change that square to cube. How are we going to simplify this mess? Which is frightening in itself, right? Okay, normally they have you figure this out at an angle. So you plug in theta value. So this thing simplifies down quite a bit. It becomes a number. Okay, but a few years ago when I was really smart, I actually have this thing worked out. Amazingly, this thing turns out to be this. That's it. Really? Yeah, you might want to distribute the whole thing, and yeah, it's a gigantic mess, but they simplify quite a bit. A lot of Pythagorean the identity happens. So I will let you figure that out at home. We're integrating in polar coordinate. Wow, okay. What does it mean, right? Because if you integrate it in Cartesian coordinate, from here to here, it gives you that area, right? So if you integrate on polar coordinate, it gives you the area if there's some, let's say, do you remember a flower looking shape? Say this thingy. Well, that's ugly, but it gives you this area. You get it? So that's what integral gives you. So let's say this is tiny little infinitesimal, the theta, and we have to calculate that area. Do you remember area of a sector formula? What is area of a sector formula?
N over 360 pi r squared.
Oh, okay. Oh, you're gonna go do it that way, right? Theta over, or in this case, the theta over 360 times pi r squared. Okay, let's go that way. Good. See the pi's cancel? So we have 1/2 r squared d theta. How about that? Okay, y'all got it? Do you like to know where this thing came from then? I mean, it's geometry, but I can teach you. Okay, let's go back and review all of this. Wow, 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 wow. This is disturbing. Calculus BC students don't know basic geometry. Okay, suppose we have theta, we'll just call it theta. And this is R, okay? Let's review that S, arc length. Arc length used to be R theta, and this is how where it comes from. Do you see theta to 360 is the same ratio as S to the circumference? Do you see that? So your S is equal to theta to 360 times the circumference, eh? You with me? So your S is equal to R theta. That's convenient formula. Make a note of it. This is important. Likewise, theta to 360 is the same ratio of that area of the sector to the area of the circle, correct? So the area of the sector is equal to theta to 360. This is what we just did, times area of the circle. And that gives you 1/2 r squared theta. How about that? Okay, so let's remember this. Well then, so in this case, your dA, because this is infinitesimal, tiny little, right? And that's 1/2 r squared d theta. How about that? Okay, we kind of need that. Okay, because now we're going to calculate the area inside of this cardioid, but outside of the circle. So we are looking at this area right there, that one. You. How are you gonna do such a thing, right? Okay, so let's take a I don't have a sector drawing tool, so I'm gonna have to do it with a line. Okay. I'm gonna draw this tiny little somewhere here. Okay. And I'm gonna draw another one. And say this is infinitesimally thin. Okay, so this picture is what I have up here. This is the data right here, and this length is r. I mean, it varies a little bit in this case, but still, you know what I'm saying? Okay, so that dA is equal to 1/2 r squared d theta. So far with me? So far with me? However, I have two of them. So which one are we talking about? U. Okay, so I'm gonna have to say this one is R1, which is equal to sine theta plus 1. Good. And the other one is R2 here. I'm gonna say R2 is equal to 3/2 constant function. That's ugly. So far with me? So looks like I'm gonna have to draw another one with a less color coordinate. I regret not making this blue, but this is a computer. Hey, it's a blue graph. So I'm gonna draw another sector here. The other one going that far. Like that. So this is R2. You get it? Where this was R1. So we have to subtract the area of this sectors, because what we are really dealing with, what we really want is that much now, isn't it? Okay, so let's subtract minus 1/2 R2 squared d theta. Are you with me? Okay, neutral color, black. I'm gonna factor, so 1/2, and then we have R1 squared minus R2 squared. This is generally how it's going to work out. You get it? Because if it's the area between two curves in Cartesian coordinate, it was just y1 minus y2, right? This naturally is a difference of square, and that comes from this important area of the sector formula itself as an r squared in it. Get it? So let's not get that one confused. And once again, it's not the quantity square, it's the difference of square, okay? Very, very important concept. Okay, now we can simplify this. R1 is, of course, sine theta plus 1/8. And then minus 3/2 squared, and then we have d theta. With me? With me? Okay, let's simplify because integrand is important. Okay, so we have sine squared theta plus 2 sine theta plus 1, right? And then minus 9/4. So do we have minus 5/4? Too much algebra? You with me? Okay. Now, do you remember what to do about sine squared theta when you want to integrate it? Told you this thing never goes away, right? How many times did I put this on the test so far? You remember this thingy on the test? I think it happened multiple times already. Maybe you didn't get it, so you don't remember. Do you remember missing it? Do you remember the frustration not being able to solve? Okay. So somebody tell me what that is while I write the rest of the things.
1 minus cosine 2 theta over 2.
Thank you. This should be automatic. I mean, it's like reflex kind of thing by now, right? Still with me? You see why you don't want to do all of this inside the integral? It's pain in the butt. Okay, now we'll really simplify. So 1/2. And then, okay, there's a -5 over 4, and there's this half, which is 2 over 4. You know what I'm saying? So we have -3 over 4 together. Once again, that's 1/2 and -5 over 4. I combined it. Minus 1/2 cosine 2 theta plus 2 sine theta. You with me? Now we're ready to integrate. Okay, let's integrate. So our A is, oh, from what to what? What is this angle? Actually, I regret changing the color. I'll still go with black. It appears from the picture we want to integrate from here. Whoops. Uh-oh, it's misbehaving. To here. Right? So it appears our limits of integration, it happens only there, so this is pi over 6 to 5 pi over 6, right? But do you really want to graph anything this accurate in the middle of the test? You don't even have a polar grid. I mean, you're using graph paper, but not this kind of graph paper, you know what I'm saying? So there has to be a way to calculate this, right? Yeah, this is time to do that algebra, right? Because what we are saying is A here is equal to something, right? And we want to say pi over 6 to 5 pi over 6, but come on, right? There's no way you can feel it that well. So here, remember algebra, geometry column, calculus column tactic? That works really well. So we have to do this. You set them equal to each other. You get it? Say yes. So R1, remember, was sine theta plus 1, was it? Yeah, I think so. And then the other one is 3 over 2. Ah, we're solving trig equations. Hopefully you remember trig equations from last year. This one is really easy one, right? So theta is equal to pi over 6 or 5 pi over 6. Ah, so we can say pi over 6 to 5 pi over 6, okay? Or, wait, does that look symmetrical to you? Yes, it does. Symmetry is always nice. So whenever you can, use symmetry. So pi over 6 to pi over 2. And no, what? 0? What are you doing? Double it. You get it? Okay, the reason for symmetry is preferred is next to 0, pi over 2 is also a very nice number in polar coordinate. You know what I'm saying? Okay. And then we have 1/2. Oh, so this 1/2, we'll cancel that too. All the reason to use symmetry. And then we have -3 over 4 minus 1/2 cosine 2 theta plus 2 sine theta plus times t theta. Oops, my mouse is getting in the way. T theta. Okay, let's show our integrity. And those of you watching this video, in definition of word integrity, of course, means ability to integrate naturally, right? Okay. -3 over 4 theta minus this will be sine 2 theta. Let's check the sign derivative. That's still negative, but chain rule. So we need 1/4 here to be cancelled and have 1/2. And then this will be minus, right? Let's check. Derivative, negative sign, yes. And then pi over 6 to pi over 2. You and me? Now, here comes the difficult part. Okay, think like this. Instead of all of this minus all of this, I'm going to show you my dot process. I substitute pi over 2. This is ugly. Pi over 2. Okay, I substitute pi over 2 and later minus. This is how I think. You see, that's much wiser, right? And then minus 1/4 of sine, oh, that's 0, and pi over 6. So we have pi over 3. Sine pi over 3 is root 3 over 2, okay? Say yes. Say yes.
Yes.
Okay, thank you. Minus 2 of, I can't believe I'm showing this because but the students struggle with this part so much, so I thought I might show you. Okay, so pi over 2, cosine pi over 2 is 0, isn't it? And then minus cosine pi over 6 is also root 3 over 2. Tell me you can do this. Tell me you can do this. So from here you get negative pi over 4. You want me to show you how to find the common denominator and add that fraction while I'm at it? Okay, and this I believe should be 9 root 3 over 8, right? So we have this curve, right? This starts with a negative, okay? Now, and then it starts the loop. So -1, so this thing starts here, and then it goes this way, and goes around and finishes the loop, right? From the polar graphing quiz, you can feel that much, right? Say yes, not, okay, a bunch of people are nodding, and rest of you, okay. So when we have such an R value like this, our R is equal to, let me just write it this way, sine theta minus 1. Okay, and my x, we have to parameterize it. So my x is equal to R sine theta A. So we have R, which is, R cosine theta. So that times cosine theta A. And for the sanity's sake, because we are taking a derivative of this, I'm going to distribute. So we have sine theta, cosine theta, minus cosine theta. And since I really hate product rule, use the identity, 2 sine theta cosine theta is sine 2 theta. So this is 1/2 of sine 2 theta. Good? Minus cosine x, I wrote x. With me? Okay, now let's figure out y. Y, of course, it is R sine theta. So we have, this is R, that R. And then we have sine theta. Okay, so that I'm going to distribute. So I have sine squared theta minus sine theta. Good. This one is not as bad. I don't hate chain rule as much as I hate product rule. So I'm going to leave it. Now we'll take a derivative of both of them. So dx d theta. Here is, this 2 will get cancelled out and this thing just becomes cosine 2 theta A. And this becomes negative sine theta. Very good. And then dy d theta. That's chain rule. So 2 sine theta cosine theta, and then, whoa, see, this computer is misbehaving today. And then this becomes cosine theta A. Good. Now, I'm going to convert this to sine 2 theta. How about that? With me so far? Okay, so dy over dx, I mean, we can write it if you want to, but we don't have to write it. Let me push this thing down a little bit. Okay, so for your information, dy over dx, I'm going to write it over here. Different color. Dy over dx here is this thingy over this thingy. So we have sine 2 theta minus cosine theta over cosine 2 theta and plus sine theta. So far so good. Now, then we have to figure out where is this thing horizontal and where is it vertical. From the picture, you can kind of tell it's horizontal right here, right? But what's that angle? Is it 7 pi over 6 or is it pi over 6? That angle right there and up there. You know what I'm saying? Okay, so let's look at those. So horizontal first. So we set this whole thingy equal to 0, meaning we just set the numerator equal to 0, right? If you think of it as a particle motion, this computer velocity x component is here, and this is a velocity y component, isn't it? So when the particle is right there, when it's horizontal tangent, there's only x movement and there's no y movement. So this velocity component has to be 0. You get it? Think like that. It's good for you. So horizontal part, we set dy over d theta to 0. Good. Okay, I'm gonna use this one. This is easier to work with than this form. So I'm gonna say then factor cosine x. So we have cosine theta, and then we have 2 sine theta minus 1 is equal to 0. You with me? That tells you cosine theta is equal to 0 or sine theta is equal to 1/2. Not too much trig equation, right? And then, of course, cosine is equal to this. Let's just have this solution set. This is equal to 0 at pi over 2, right? And 3 pi over 2. And this, you see the problem bubbling already from the picture. That's why being able to feel the graph is one of the better assets, one of the better skills you have. And 1/2, this is pi over 6, and this will be 5 pi over 6, eh? Order is not right. I messed up the order. Let me start. Okay, pi over 6, pi over 2, 5 pi over 6, 5 pi over 6, and 3 pi over 2. Good? Okay. Now we see what, which is which. Because we only see 1, 2, 3 horizontal tangent, and we have 4 of them. So one of them ain't correct. Do you see the problem with that? Is it 3 pi over 2 or is it pi over 2? What do you say? We can plug it in and figure it out. If you plug in pi over 2 here, this is 0. So that one happens to be right here. You get it? If you plug in 3 pi over 2 here, that becomes -1. So we have -2. That's way up there. That one is correct. This is the one that will be problematic. But without feeling it, this calculus and algebra should tell us which is which. Okay? You know what I'm saying? Okay, and looks like they want the equation of the tangent line. So let's get that. So here, pi over 6 and 5 pi over 6. If you plug it into this, you are, right? I'm gonna do it at the equation of tangent. Here, different color. Okay, the equation of tangent, we want y is equal to something because it's horizontal line, right? I hope you know that much, too much algebra. And our y happens to be r sine theta, you get it? And in our case, that was sine theta minus 1 times sine theta, you get it? Say yes. So what happens if you plug in pi over 6 here? Right? Pi over 6 here makes this thing 1/2. So this whole thing is negative 1/2, and this is 1/2 again. You get it? So we get at theta is equal to, have more space, at theta is equal to pi over 6, we get y is equal to negative 1/4. You with me? You with me? And then if you look at the graph, that kind of looks like negative 1/4 down, doesn't it? That much is half right there. What happens if I put 5 pi over 6? It's going to be the same thing, right? The sine 5 pi over 6 and pi over 6 are the same thing, so I'm gonna make a little room here. And put that thing in, okay? And now, what about when theta is equal to then 3 pi over 2? Well, we'll plug it in here. So if you put 3 pi over 2, this thing becomes negative 1, So we have negative 1 minus negative 1, that's negative 2. This one becomes negative 1, so we have positive 2. Good. And let's look at it from the picture. If this computer ever moves, see, that's 2 right up there, so horizontal line. Good. Question before I move on? Okay, then let's look at the vertical tangent, shall we? Push this thing down a little more. So vertical tangent. Now, vertical tangent meaning your denominator has to be 0 in order for the slope to be vertical, right? Undefined slope. Meaning you set this thing equal to 0. So we set the x over the theta to 0. Okay, then we have, well, instead of that, I'm gonna convert, I'll just write it. Cosine 2 theta plus sine theta needs to be 0 now. With me? Okay, and of course I'm going to convert this into 1 minus 2 sine squared theta plus sine theta is equal to 0. You with me? Okay, convert that to 2 sine squared theta minus sine theta minus 1 is equal to 0. Hopefully not too much algebra. Push that down a little more. Go down. Oh, this computer is really slowing down now. Now factor. So I will have 2 sine theta plus 1 and sine theta minus 1 is equal to 0. With me? Okay, so sine theta is equal to negative 1/2 or sine theta is equal to 1. Good. Okay, let's figure out the solution set here. Okay, this is 7 pi over 6 and 11 pi over 6. And this one is at sine theta is pi over 2. Good. So we have pi over 2, 7 pi over 6, and 11 pi over 6. Okay, now we have a conflict. Because remember up here we had pi over 2 and we have a pi over 2. Now what? What are we supposed to do? Remember, that means in this case, well, this is not working. This computer is frozen. This thingy is dy over dx. So at pi over 2, from this equation, the numerator becomes 0, and from this equation, the denominator becomes 0. Give me a brilliant suggestion. When we have something have 0 over 0 form, what are we supposed to do? Oh, come on.
You L'Hopitalise it?
L'Hopitalise it, of course, right? Because there's a conflict. It cannot be both horizontal and vertical because they both want to become 0. So we want to know which one gets to 0 first. You know what I'm saying? So we have to take this little limit to settle this difference. Limit as theta approaching pi over 2 of our slope. Sine to theta minus cosine theta over cosine to theta plus sine theta. Okay, because this is definitely 0 over 0 situation, so let's take a derivative of both. And some people actually on the test try to do a product rule. No, you're defeating the purpose, right? It's a derivative of the numerator over derivative of the denominator is what L'Hopital's rule tell you. So the numerator becomes 2 cosine to theta, and this thing becomes sine theta, right? Over, and this thing becomes negative 2 sine 2, that's a weird 2 theta plus cosine theta. Okay, now let's check. If you plug in pi over 2 here, this thingy becomes 0, and this thingy becomes 0. So we have negative, some kind of 0. And if you plug in pi over 2 here, this thingy becomes 2. And this thingy becomes 1. So the numerator becomes 3. You know what I'm saying? So we have infinity. You get it? Well, we cannot say it's infinity because we don't know it's positive infinity or negative infinity. It depends on the direction this thing is approaching. But this is undefined. You know what I'm saying? So what that means is this is vertical at theta is equal to pi over 2. That makes sense to you? Right? Undefined slope is vertical, 0 slope is horizontal. And my OneNote just crashed. Okay, let me try to revive it. This computer is struggling. Hopefully, it usually saves everything. Okay. It missed. So at theta is equal to pi over 2. Are we good? Then we have to go back and delete that one from the solution of horizontal tangent. You get it? Okay, now let's find the equation of the tangent line here. I'm gonna squeeze it down here. So equation of tangent. We just need x is equal to something. You know what I'm saying? And then our x. Oh, it changed the color on me. Thing. it is r cosine theta, and our r is sine theta minus 1 times cosine theta, isn't it? So if all we have to do is just plug these guys in, right? Okay, and then from the picture, we predict here's 1 and here's 1. You know what I'm saying? And then here's 1. This is still vertical tangent. Okay, let's start plug it in. So at theta equals pi over 2, our x will be, if you plug in pi over 2 here, this thing becomes 0, right? So we don't care what that is, so it's 0. Ah, that's the one in the center. Good. Say yes. Okay, and bring that thingy down. We have at theta is equal to, let's say, 7 pi over 6. Then x will be, so 7 pi over 6, that's negative 1/2, right? Right? And minus 1, so negative 3 over 2. Good. And then 7 pi over 6, I'll just write it down. You guys look. So we have negative 1/2 minus 1 times cosine 7 pi over 6 is another negative root 3 over 2, eh? Good. So we get x is equal to, this is 3 over 2, so 3 root 3 over 4 is the vertical tangent on the right hand side. And lastly, this is equal to 11 pi over 6. Your x will be now still negative 1/2 minus 1. This one is the same, but this thingy, cosine 11 pi over 6 is positive root 3 over 2. Good. So we have x is equal to, now this time negative 3 root 3 over 4. And that's the vertical tangent on the left. How about that? Good. Okay, we'll do number 12 now. Let's take a direction. Let's take a look at the direction of number 12. What do they want? Same thing? Right, vertical and horizontal. Yeah, looks like it's the same thing. The reason that this was more confusing was that these trig equations we get here is not factorable. Okay, but otherwise the idea is exactly the same. So we go back, x is equal to here, r, this is our r, 3 minus 4 cosine theta times cosine theta. Okay, and that distributes, so we have 3 cosine theta minus 4 cosine squared theta. Good. Okay, I'm gonna leave that. And y here is 3 minus 4 cosine theta times sine theta. Okay, so that is 3 sine theta minus 4 sine theta cosine theta. And knowing I'm going to differentiate this, so, and I hate product rules, so let me convert this into this thingy. Good. You with me? Okay, let's take a derivative of both. So dx over d theta will be negative 3 sine theta, and this will be 8, right? And then cosine theta, chain rule, negative sine theta. Good. And I'm gonna convert this into negative 3 sine theta, and this will be 4 sine 2 theta. How about that? You with me? Okay. dy over d theta here will be 3 cosine theta, and that will multiply, so it will be 4, and then cosine 2 theta, 8. Symmetry is pretty striking when we are dealing with cardioid here, right? Okay, now, so which one first, vertical or horizontal? Your choice. Oh, cardioid, this is Limassol, but whatever. Oh, just pick one. It's not a trick question. It's just, we're going to do both, but which one do you want to see first? What's the question? Vertical. Okay, so let's do vertical. So vertical meaning your denominator has to be 0, so we set this thing to 0. Good. Okay, now, and here's the, well, this one actually works out nicely. Actually, not so nicely. I'm gonna use that one and factor. So there's a sine theta outside, and here's our problem. We have -3 plus 8 cosine theta. You know what I'm saying? That is equal to 0. So that gives us sine theta is equal to 0, which is nice, or cosine theta is equal to 3/8. That one is not nice. You know what I'm saying? Okay, so we'll have to use our calculator skills, but here, so our theta should be, for 0, this is easy, 0 and pi. And the other one, do you remember if you put inverse cosine, then you get first quadrant angle and second quadrant angle, and then you have to make sure these are correct? So let's see it. Right, first we are looking at vertical, so yeah, there's a vertical, and the other one will be somewhere, well, here, right? This gives us fourth quadrant angle. We expect our fourth quadrant angle, and we want this one, right? And we want that one. So 0 and pi is here, here, and here. This thing starts here and then go around like that. And then we want, right? And then if you just plug in the calculator, you only get one of them. You know what I'm saying? So do you remember how to get the other one? 360 minus the other one, eh? Okay. I don't have time to teach you how to do that, so I'll just write down the answer. So if you just plug it into the inverse cosine, you get, in degrees, 67.9756. 975687. Okay, that must be that one. And the other one is 360 minus that one. And that should be 292.024313. You know what? Actually, I can take my time to explain this. How many of you would like to see this how to calculate this one? Show virtual hand, then I will actually take time to calculate it. Okay, let's do it here. Okay, we have if this computer ever cooperates, I'll be able to explain it. Dang, this computer is slowing down. Okay, I'm gonna draw this axis here. Okay, we have two triangles. This will take forever to draw this triangle. Wow. So one of them is right here. Let's say it looks like that, 67 degrees-ish. We just got faster. And then from our knowledge, we know there are two of them, and one of them is in the first quadrant and the other one is in the fourth quadrant. Do we know that much? This cosine is positive here and here. You know what I'm saying? So this one, this angle right here is 68 degrees-ish. That's this much. You know what I'm saying? And using that, how are we going to calculate this? Because if you just press inverse cosine, it only gives you this one. The other one is negative, which will go into second quadrant, which we don't have. You know what I'm saying? So, but this angle is exactly the same as that angle. It's congruent angle, isn't it? So this one should be 360 minus 68 degrees-ish. Does that picture make everything abundantly clear now? Where the other one comes from? Who still has a question on this? This is kind of stuff that people never understand during pre-calculus. Are we good? Okay. Then we can do horizontal now. Okay, horizontal, you set dy over d theta to 0. Okay, so what we have is that thingy over there, scroll. So we have 3 cosine theta minus 4 cosine 2 theta is equal to 0. I'm going to convert this thing to 3 cosine theta, and I want to convert it into this one now. 2 cosine squared theta minus 1a. Okay. So distributing, so we have negative 4 cosine squared theta, and then plus 3 cosine theta, and then plus 4. Oh, I screwed up. This is 8. Good. Okay, now, I mean, it's a preference. Do you want to multiply negative 1 on both sides? Because this doesn't factor either way. So we are looking at quadratic formula. Let's work with this or multiply negative 1 on both sides. It's not a trick question, I'm multiplying it. Good. Now, activate the quadratic formula program, which I showed you. Then you should have cosine theta should be something, or cosine theta should be something else. What are they? Oh, you don't have that program. Didn't I tell you that will come in handy? It might come in really handy on tomorrow's test. Remember, you needed quadratic formula in some of these things, like projectile motion. What do you have? Okay, so let's get 0.9190437. It's one of them, and the other one should be negative 0.5440. 437 is what I got from the Dropbox note. Okay, can at least somebody press inverse cosine for these things? Because I don't have that much.
Mr. Kim, you
Yes.
missed the coefficient in front of cosine theta.
Repeat the whole thing?
You missed the coefficient in front of cosine theta. It should be 3 cosine theta.
Oh yeah, when I was erasing that positive sign. Okay, pressing inverse cosine button, what does that give you? Wait. I think I might have messed dy over dx. No, I didn't mess it up. If you don't do it, then I'm gonna stop because I really don't want to get my calculator out and do this.
122.959341 degrees.
For which one? The one on the left or one on the right?
I think it's for the one on the left. I mean, on the right, my bad. The
100?
Yeah. 22.959341.
959240.
959341.
959341 degrees, and the other one?
It's 23.2133.
Can you repeat the whole thing?
23.21332.
I need one more digit.
Oh, 3325. 25, yeah.
25. How about that? Okay, let's just look at the picture and just to make sure we got those right. 23 and 120-ish. Okay. Yep, right, 120-ish. 23 is not correct, right? 23 is here, but so what do we do in this case? You see what we have to do? Aren't we glad that we decided to do this in the class? So we have to draw the picture again. Okay. So we got 122 correct, which is this one, somewhere here. This is 123-ish. And then 23 is this one. Somewhere here, right? Why is it not turning out to be? I'm not sure if 23 is correct. Can somebody double check? Because I get a feeling that it should be symmetrical and up here on the picture, right? Because what we are really looking for is computer in this high-tech age. We are looking for this one. You know what I'm saying? So can somebody double check this?
23 is correct as well.
Okay, can somebody double check that one then? Or can somebody double check my quadratic formula? I mean, one of them is actually looking at it. Yeah, that sounds about right. Maybe this is wrong. Otherwise, we don't have symmetry, and that's kind of problematic. Come on, people. We are on the recording.
Both are mathematically correct according to our calculator.
Okay, we'll just go with it then, right? So this is 23-ish, which is not the correct answer. So how would you calculate this one? The red line. Do you see this has to be 23 plus 180 now? Like that? Right, so this is kind of deceiving. This is not the real answer. The real answer here is this thing plus 180. 180, so we have 203.213325. How about that? That's a real answer.